So also a welcome from my side. I'm Rene from Austria, where is Limbit located. I work for Limbit since 2017, so nearly 7 years now there. We do Linstor. I mean, originally Limbit is kind of famous for DRBD, if you know that. It's block replicating storage, which is integrated in the Linux kernel. But I was mostly had Linstor where it is now, nearly from the beginning. I'm also doing the CloudStack plugin for Linstor to provide storage, primary storage provider for CloudStack. Yeah. So, what are Linstor's goals? It's kind of a management software for your for providing volumes to your hosts. In the case of CloudStack, I mean, in most other cases too. It's built as it uses building blocks from the whole Linux storage universum, you could say. So we don't reinvented the wheel, so we use LVM and ZFS for providing our volumes and put basically DRBD on top of that and provide it to our SDS consumers, which are any kind of CloudStack, Kubernetes, OpenNebula, Proxmox. Yeah, as I said, these are the most used ones here, the volume for volume management. We have also some providers where you can use kind of a file provider, which more used for testing. So if you don't want to create an LVM pool, you can just try it with a simple loop device file. Our deployment architectures are distinct storage nodes, so you have distinct hosts which are just there to provide lots of storage, so like free storage nodes, and then you can have up to 100 host nodes which are running actually the VMs without any storage. So we have some kind of, it's called diskless mode. So then every read and write is done over the network, and you don't need local storage for that. But we also have the possibility of use hyperconverged storage. So when the hypervisor, KVM in this case, and the storage is on the same node, which provides a bit more performance because reads can be done locally, and not only the writes has to go to at least a second node to provide the replication. Our software is all open source and GPL. Just last week, I mean, we have, from the Limbit perspective, we have still one closed source product, but it's only for customers. It's for geo replication. So if you have a not so good network connection to your other location, and we want to replicate over that, we have some kind of buffering software for that, but that is closed source. But since last week, we also open sourced our Linstor GUI, which is some web GUI for managing Linstor, which was also open sourced last week. So, bit overview for anyone who never touched Linstor or never checked it out. The design, the basic design of node and management is like CloudStack. So you have, we call it Linstor controller, which would be the equivalent to the CloudStack management server. And then we have Linstor satellites, which would be the CloudStack agent host. Then you can talk to the Linstor controller over a REST API. And we have a CLI tool for managing, and since last week, an open source also a GUI for that. And here is kind of the thing So here you have 2 nodes with storage. Also on the controller node, there's a storage node, and then you have 2 additional hosts, which only work as a diskless node here. So CloudStack support started in version 4.17 with volume snapshots and live migrate. Then in 4.18, we also added IOPS support, and so the backup snapshots, so a mode that which you also have default, so that snapshots you take in CloudStack will be copied over to the secondary storage. You can turn that on or off. In 4.19, I missed it a bit. You would also need for the last 2 points, it's only available in 4.19.1. And I had this twice. Okay, my error. Sorry. We now also support VM snapshots without memory, and HA support. Thanks to Slavka for providing the basic interface for that. So we just had to implement a few methods or functions and the interface, and now the Linstor plugin can also do H8. For that, you had to at least have some kind of dummy NFS primary storage where the heartbeat checking was done. And then since the work from Slavka and Sorpool, you can do that now just with Sorpool and Linstor 2 without needing any NFS primary storage anymore. So the main topic of this talk, VM HA or host HA. So there are 2 different concepts in CloudStack. VM HA you get kind of by default. For host HA, you would need to set up an out-of-band management. So like IPMI, you have to set that up in CloudStack, configure that, setting passwords. And then CloudStack will try to fence the other host if it goes down. And for Linstor, we don't need host HA. So that's what we recommend our customers is only use the VM HA, because Linstor and DRBD with quorum, so you need at least 3 nodes for the quorum majority, takes care of that split brains don't happen. So if one node would get isolated, and then it would say, okay, I don't have quorum majority. When I can show you the next how does it work. So you need, as I said, 3 nodes minimum, but the 3rd node could be a diskless node. It's just that you need some additional voter to have a majority on one side. On the starting state, we have the 3 nodes. Like in the graph here, AC would have storage, B is diskless. Then the first connection drops from B to C, but DRBD would still know, okay, everything is good. We know who is primary. So, DRBD uses a primary secondary, so active, non-active concept. So only one node can write to the storage at the time, with one exception, but I don't want to get too into detail there now. So let's say if here A is the primary and is currently writing, then the second connection drops from A to C. We now know C wouldn't know by default with no quorum. Could still happen if it was primary that it would write. We can go over this scenario again with what will happen if C is primary. But for now, we assume that A is the primary currently, and A knows still has a connection to B and knows I'm 2 against 1, so we have the quorum majority, and I can still write to my storage. And if also the connection to B would drop, A would remember that it had the quorum majority, and B didn't have a connection to C, so it can still keep the quorum majority. So DRBD has to take track also on previous states to work with that. And in another case, where let's say in the starting state, C would have the primary role and would where the host is running, and drop one connection, still good because we know we have the majority. But now if the connection to the other two would drop, C would know, oh, I don't have quorum anymore. And in a usual CloudStack environment, you would configure this node to suspend I/O if it doesn't have quorum anymore. So any write request from an VM on that node would still wait. Will probably run maybe in a timeout, but would just wait. And if these are brief connection losers, like you pull a cable from the switch and pull it in again, or like there are also cases where the network isn't that stable and you lose the connection for half a second or a few milliseconds, and then now milliseconds, not let's say seconds, because we have higher timeouts for that. But that could happen. And if the connection is regained to a C or BC, then the VM would just continue working because it just had a long delay to write. Like the layer below didn't answer for that long, but then the VM is still running. There are other options, like could also be configured to say, oh, I don't have quorum, I throw an I/O error, but that's usually a bad situation for virtual machines, because then there would I/O error, and usually what happens is then that the root drive would be mounted read-only again, and then the only thing out of that is by manually remounting it with read-write, or most of the times also the VMs just get the kernel panic or stuck, and then you have to reboot them. But with the suspend I/O setting, they will just continue working again. So here, just what I explained. These would be the recommended settings you should set if you have a CloudStack setup or any virtual machine-based setup. So suspend I/O for on no quorum and on no data accessible is another case if you have a diskless node, like in a non-hyperconverged setup, because they don't have data at all. And that's their setting to say, okay, suspend I/O until I can read again. And these are basically the Linstor commands to do that. So I prepared for this talk and tried to figure out how you can minimize the timeout or the time until CloudStack knows what happened. And so this is the process CloudStack does to know how a node goes down. So first thing it would be the node disappeared because either a power failure or let's say the network is down to that one node. Then after some time, CloudStack would recognize, okay, there is a ping timeout to that node. I think it even waits 3 ping timeouts until it really decides, okay, I have to do more checking. And then there is a command check sent to all agents in that cluster, even to the node that is not reachable anymore, but also to the other nodes. And of course, to the node that's not reachable, you usually don't get any answer at all, so it's a timeout again. And the other nodes have the chance to check if they can reach that node. And yeah, in the most cases, the hosts will not respond. And so this is the case where we send the message to the host itself. And the other cases, the other hosts would say, okay, I can't reach this node, so it must be down. And then CloudStack would say, okay, nobody can reach this node, so it must be down. And then the whole CloudStack HAVM starts. So it starts to restart or start all the VMs on other nodes, and declares this one down host is really down. It takes this to happen. And yeah, this is the function that's actually called on the agents. So it's called check heartbeat, which gets an KVM pool in our case, and the host to check for. But this host can also be yourself or the name of the other node. And what happens in the Linstor plugin here is, if it's the local node, it parses the DRBD setup events too, which is an event stream from DRBD, where you get all current states at first. And if you would not have, say, now, because now we'll just get you the current picture of the events, then it's just an event stream, and you would get connection attempts and dropped connections and such stuff. And in this output, we check if any resource on this node is primary but has a promotion score of 0. The promotion score is some indicator on how likely DRBD thinks it should get primary on this node because of certain assumptions. I don't know the details. This is from DRBD developers. But if it's 0, it don't want to go primary, or it can't even go primary if it has promotion score 0. So that's an indication for us. Okay, we have some problem because we can't reach other nodes and we can't get primary. So there must be something wrong. And other nodes check the output of DRBD setup status, which is not exactly the same because there is no promotion score included in the output. But this output includes all the connection states to other nodes. And if the local node has any connections to the other node, which we want to check for, we know, okay, we can reach it, and everything is fine from our side. So that's the indication, okay, this node is fine. And if it wouldn't have any connections, we say something is wrong here, or it's probably wrong, because it could also happen that we don't have any connection to the node because there is no found resources to that over the two nodes. But then we still have to say no because we don't know better. So, and as I prepared for this talk, I wanted to try on how to get the timing lower, or the time lower, until CloudStack decides that a node is down, because for Linstor DRBD, for that setup, as split brains can't happen if everything is correctly set up, we would rather have very short times, because a split brain can't happen. So we don't need long timeouts and fencing and all that stuff. So for if we would know, okay, this node has no connection, then restart the VMs on another host. So first setting is for simple setup, you just say force HA to true, it's a boolean, and then every VM in your setup will be handled as if they have HA enabled. If you want to do it properly, you would have a compute offering where the HA is enabled, and use that for your VMs which have an HA offering, maybe for your customers or something like that. But for simple setups, you can just enable this one here. Then every virtual machine is handled used as it would have HA enabled. And then there are a lot of hypervisor QVM settings. But all of these, I don't even want to read them now, they don't matter for Linstor because these are mostly used for host HA, which we recommend not to use. And so right now, in the current state of CloudStack, is you have to use the wait setting, which is very good hidden. And it's actually the basic timeout setting of commands. So it has a timeout currently of the default timeout is 1,800 seconds, which is 30 minutes. But it comes down to, for other reasons, I get other timeouts then take over, is that in my tests, a default failover or until CloudStack recognizes that it is that the node is down, took around 15 to 18 minutes. It's quite some time if you think of it, that you don't need to wait that long. And then I investigated further and I found some missing code, it seems, which so basically a bug. And I already have a pull request for that up. It needs a review. I'm not sure if it gets in 420 because it was only submitted last week. But with this, then the failover only takes, or the recognition that the host is down only takes 5 minutes. And you can get that even further down if you lower the values of the settings of ping interval and ping timeout. Ping timeout is the default 60 seconds, and the interval is some multiplicator for that. So if you set that lower, you can get down to 2 minutes with this fix, which is currently under review. So, and time, okay. I will show you a live demo of that, but with the shorter timeouts because we don't want to wait 15 minutes. So I have here one management node, which has a management server and 3 hyper-converged nodes with Linstor. So agent 71, 72, 73. And we will power down or force power off agent 73. And there should be currently, we will see that now. Get the screen over there. Hey. Should I make it bigger or is it okay? Okay. That's good. Or yeah, that's so. Okay, we have here 6 instances running, and 3 of them here on 73. And so over there. You know what? Very. Okay. So yeah, this is our Linstor cluster. This is the node output. So we have 3 nodes there. Then this is the current resource list for all the resources we have there, and we'll also show you the So these are the resources that are currently running on node 73, and these are our 3 virtual machines, basically, which have in use. And the others are replicas used for quorum, or diskless, or also as really storage replicas, because I have here set up as a cluster with replica count 2. That means there's always a second copy of the data. And sorry, it's not my keyboard. And now I will just destroy node 33. So that's gone. Linstor already should have recognized that. Yeah, it's down here, and you will see a lot of connection warnings, unknown states from there. And now follow. Oh man, good. Agent log. And then F. Now it's at the bottom. So you would see this debug mode enabled. Probably hard to see, but here you already see that we have some DBDZ events 12 calls, which are triggered by the check heartbeat commands. Just don't know if it's currently because of the can also check the server log. We should, when it's a lot more output, there is a lot more going on, but you usually see when the VMHA starts to kick in, because there is just a lot more going on. We may see some ping timeout message here. Of the following agents behind on ping, this 3, that's the ID of the host. This happened here yet? No. Here another timeout of host 3. And I think now I have the default setting, so it should take around 45 minutes, so it should be close. Yeah, I think now it started. Oh yeah, we didn't even see it, so they are already switched over to 47.01 and 47.2. So, and you would now also see here in the infrastructure on the host that the T33 is down. And before, we would still wait, because it will please take 10 more minutes until this was recognized. Yep. So yeah, there's some time. Perfect. Any questions? Yes. No, that's not decided by Linstor. That's decided basically by CloudStack, because No, that's because of CloudStack starts the virtual machine on that node, and that is we have some kind of auto promote, which means in the default, if you don't use the resources, they are all secondary. And the first one who wants to start right to that block device will auto promote it, so that will get automatically primary. Forces, yeah, it decides, okay, I want to start it on that node, and then it would fail. Then you would get an error in CloudStack because it can't start the virtual machine because no, not even that. You could only have 2 CloudStack nodes, and you just need a third tiebreaker node for Linstor somewhere. It could be Raspberry Pi, and it just needs to be part of the Linstor cluster, but it doesn't need to know about anything about CloudStack. Yeah, thank you. No, our recommended on default setup, is that you would have, from Linstor perspective, you have a LVM pool or a CVS pool below. You give that pool basically to Linstor, and Linstor flashes out tiny volumes of that for CloudStack. Or not tiny, the requested sizes CloudStack tells you it wants to have.
All of it's not seized.
Linstor does that for you. So that's what Linstor does. It flashes out the LVMs, puts DRBD configuration on it, and provides the dev device then to CloudStack. So basically, that's. Yeah, our recommended way is to have below an LVM or ZFS because you're more flexible, and then put a DRBD on a volume in that pool. Until you know you will never need that because you have a very static setup or static. But then you could also argue, do I need Linstor for that? Because then you write your configuration file one time and be happy with that. That's your decision. I don't think there is any kind how you could do that. There is one thing which, if you want, because you mean if your hosts have different performance or. So you mean you don't want to have the VM run on an tiebreaker node or on a diskless node? If there are always diskless, you could use tags, I guess. So you could just tag the hosts in CloudStack. No, and the other thing is, but if these diskless nodes also have storage, and it's just because it's now a tiebreaker, then there's a setting in CloudStack which is called auto. When you use it, you don't know. Okay, there is a. this is a Linstor setting or property, and you can configure that. And if, like Sven said, if you have that primary for more than 5, 10, whatever you configure. Hello? Whatever. It will, we call it in Linstor toggle disk. So it will carve out from your pool a volume and replicate it there, and then you have the certain performance numbers on the others. Yeah. And also in that step, then we have some balance task, which if you're enabled, it will remove the additional replica from the other host and will toggle this to a disk class again. So you don't waste space, basically. All right, then. This